Okay, welcome to my talk, Managing External APIs in Enterprise Systems. My name is Pete Muldoon, and I work in Bloomberg. I'm an engineering lead there. So, who am I? Who is that dashing guy in the photograph there? So, I started using C++ professionally in 1991, so I've been using it a very long time. As far as career, I've been a system analyst and architect. I spent 21 years as a consultant. That just means I've seen a lot of different places, a lot of different projects moving around. And the last 10 years, I've been in Bloomberg, and I've moved around inside of there quite a bit too. But right now, I lead a ticker plant migration initiative, all right, which is a lot of enterprise stuff. What do I like to do? Well, when I come to conference, I like to give talks focused on what I call practical software engineering, meaning it's something you can, it's in the real world, right? Because that's where I live, so I try and program there. And I try to make it so you can take something away. It's not just a very esoteric talk that you say, that was interesting, Pete, now I'm going to go do exactly what I used to do before. All right. So questions, there are slide numbers in the bottom right. I will pause every so often to ask for questions. And if you can give me the slide number, it's just easy to get back to it. All right. So where will we be going with this talk? Well, this talk will be about using APIs in your application. Not about writing APIs. There's lots of stuff out there, and we'll talk about that. It's based on a real-world system, and I'm going to talk about the engineering decisions that were made. All right? So this is not theory. This is about a real-world system. It was a rewrite of a very large enterprise transactional system in Bloomberg that I was part of. And there were early design decisions that were made prior to my joining the team. I didn't agree with every one of them, but I will try and justify them, right? And set the table, because we have to set the table before we can actually get into the talk proper. Now, other ways of getting this stuff done could have happened, and probably there may be better ways. But I have to deal with what we did, right? So there's stuff I would like to maybe sweep under the carpet, but I won't. But the main focus of this talk will be handling change in a live production system. And what I mean by a live production system means it's a system you can't just take out, you can't have it go down, you can't have it be unreliable, because there will be consequences. In the line of work I am, because I work with Bloomberg, if we get it wrong, we have reputational damage. We can be fined by DTC for doing the bad trading, right? We have, the client can terminate the contracts. There's a lot of bad things that happen if we don't get it right. So we're not in a very fault-tolerant environment. So let's talk about enterprise systems. When we go to write, especially with a rewrite of an enterprise systems, we do not want to write all the software ourselves, right? We want to more or less bring them together and sort of be the glue. I don't want to write everything myself. So we use many APIs, and these APIs will give us a variety of things. Some of them are here. We need some way of having a database. We want cache maybe for fast reading, IPC to talk to other services or send it outside our system. And there's other APIs that give us particular functionality. Now, if we need matrix multiplication, we probably don't want to write it ourselves. So my line of work with these provide for me is reference information. And that means if I get an action, which will normally be a trade coming in, it'll be on this security, it'll just have some kind of handle. I'll go somewhere and pull that information. Who's doing the trade, I'll pull that information. What is the trader privileges, that information. So I'll pull a lot of information. And I use APIs to do that. I'll need persistence because I have to keep the state. I can't just say at the end of the day, the state gets wiped out and we start it the next day. All right, so I need persistence. I'll use a database. And then I'll need some way of sending or propagating my side effects, which would usually mean sending it downstream or down into a pipeline. But they're an important part of any system. And we usually drag them together in an enterprise system. So let's talk about APIs. What's out there? So before I do a talk, I want to see what kind of coverage has been done before and not just trod the same old ground. So when I put in APIs and conference, something like this comes up. All right, it's not an exhaustive list, but what it is, creating APIs, the most important design principle, principle of least surprise in an API, Back to basics in this conference, API design by Jason Turner. So we have a lot of things about writing APIs and what I'll call the producer side of APIs. But there seems to be relatively little about the using or consuming. How, as a savvy consumer, can I use APIs inside my system? And that's what we're going to be covering in this talk. So APIs. If we talk about good API design from a producer, what am I looking for? Now, I'm going to give you a very short list of bullet points, these 2-day courses on how to do this, but to me, I'm going to sum it up in that if I'm a producer of an API, I want general use and flexibility and a lot of available modes of operation because I want to make it popular so people will buy it and pay me money. So it has to deal with a lot of situations, very wide. Also, we want it testable, right? In this day and age, we should realize dependency injection is key to code quality and reliability, and some good ergonomics and documentation. It's not very hard to use it. But on the other side, I have the use of these APIs as a consumer. What am I looking for? Right? And as a consumer, I'm looking for specific use, specific outcomes. I don't want a huge wide API. I want some constrained modes on it because I don't want people using this API in 20 different ways to do the same thing, right? Or do bad practices, or, I'm in a hurry, we'll do it this way for now, right? And we also have this code efficiency. So there's certain things I'll do whenever I'm doing some operation. I'll just bundle them in as part of the wrapper for the API. But if you look at the top 2 points on the consumer and producer side, you see they're going in the opposite direction. Right? As a producer, I want a very wide, very flexible API, and as a consumer, I want it narrowed down to specific use. So how do we normally bridge the gap? We usually do that with a wrapper abstraction. And there's this rare, I don't think I've seen a project where they'll just use some third-party database as is. It'll be wrapped in a database class, or if you're doing some cache, it'll be wrapped in some cache class, right? We'll constrain it to manage what we're wanting to do with it. All right, so here is a very simple diagram of the system I'm going to be looking at. All right, all that happens is users send in actions or requests for things they want done. Based on what's in that, I'm going to pull a bunch of referential data from somewhere. I'm going to mutate the state. I'm going to figure out who owes who what sums are changing. And then I'm going to save that state in the database. So if I, God forbid, crash, or I shut down at the end and I come back up, I have the same state. And then I have something to propagate the effects out, right? So someone on their screen sees what's going on, or goes down, in my case, to DTC or trading or out to a broker. The thing about my system and many systems is they're part of a pipeline, right? So like my outputs are someone else's inputs generally. And I have no guarantee on how stable the other application is going to be or what it's going to require of me in the future. But for our purposes, I'm going to go back to my sort of full system, and I'm going to take a slice out of that. All right, so we had a system where I needed to send requests out to this service to say, here's what's happening, here's the side effect, here's the trade that just occurred. All right, and that went down through the broker. Eventually, we get to settling. And I get a response back of how well that went. All right, so let me get rid of everything else and just say, here's what we're going to focus. So we're going to single out a single request response API as far as the demonstration goes. So we're going to take this piece of code to demonstrate a principle. The code itself is, I would almost say, secondary. It's just what we're doing and applying some engineering to this problem. So in Bloomberg, I'm given a comms API. And it's a very, very wide API, right? We have, here I've just put the blocking send. So you send the request, you block till some system sends a response back. And then we have an asynchronous version where you send the request out. And then there's a callback object you give it, right? Which has to have a certain parens operator that takes a certain set of parameters. So these are the two that's used a lot, but it has sends, which is send one way, meaning just send it, I don't care if anyone gets it or not. You have send one way with ACK, meaning send it, and as long as it got there, I don't need a response. We have all kinds of difference encoding, bear encoding, JSON, XML. We have whether we take structured data, blobs. So this thing is wide and huge and can make your system very messy if everyone just goes and picks a different part of it to use. All right. And again, this is going to be based on what was really done. It's a little simplified for the slideware. But the one thing I want to let you know is that that async callback gets a response passed to it in this API's version of a unique pointer. They called it, I think, a managed pointer. But it was similar to a unique pointer. C++ didn't have it at that time. This is an old API. And that pointer had its own allocated memory. So the callback gave you a piece of allocated memory with the response in it. So I want you to remember that. So I come along and I want to constrain this API and get good practices, okay? So I'm going to call mine a service, because that's what we call it. And I think, templating on request and response was a good thing, because these requests and responses are many and varied. Even within my system, outside in the whole enterprise system, these are generated someplace else. I have no control on them. So anyone can say, this is my request, this is a response. Excuse me. So I have a response. I'm going to say, well, look, I'm going to send a request, get a response back. And one of the design decisions or engineering decisions that was made in our group was that the response can be very large, and we want to limit copying. And certainly want to limit copying where people don't even realize they're making copies, right? Which is what happens the most part, especially when we're sending vectors of things around. It's like, yeah, we got move constructors here, and turns out you didn't put the no except on it, right? So you get copies. So as good as everybody thinks they are, you'll make unintentional copies elsewhere. So we wanted to take a grip of that. So we decided we would make a response carrier, templated on the response. And what I want to make sure is that this thing is move only, all right, that it is not copyable. So anyone here can help me out. How would I do something like this? Okay, so I'm hearing a lot of delete the move constructor. I want to actually move it, so I wouldn't delete the move constructor, right? I think you meant the copy constructor, right? So we delete the copy constructor. Okay, that'll certainly stop us copying this thing around. I got to remember, I don't know if the rule of 3 or the rule of 5, there's some kind of rules I'll have to look up. And then what am I going to take? I'm going to take charge of the memory, so I have a raw pointer. I'm going to, free it in the destructor. So this is a path you can go down. Anyone think this is a good idea? I think this is a bad idea. Yes, someone came up with the answer I'm looking for, which is I want to make my life simple. They came up with a unique pointer for exactly this ownership problem. I no longer have to worry about it, and because the unique pointer has its copy constructor deleted, it means this object has its copy constructor deleted. So this is great. So far, so good, and that just means they're going to say that instead of returning a response, I'm going to return this carrier of the response. Now, if someone needs to make a copy, they will be able to do it, but they'll have to work at it, and that's okay. So next thing is this is a synchronous call, and I want to make an async version of this. I don't like synchronous calls in my system. I have to ferret them out. So I want to make sure we're async only. So how would I do that here? Because remember, we're just constraining this big API. Via callback, that's what the old interface gives me. I don't like it. So a future, yes, right, look. We've all gotten into the whole idea. Whether you like futures promises or not, they're here. We know about them. If I put them in here, I don't have to explain to the guy, this is, my, some strange named pointer coming back, right? So I have a future. This makes it blocking. Everything is great. People should be able to figure this out. Now, on the system we're going to look at, it had its own coroutine library. So we could have 50,000 coroutines of separate threads of execution, not separate threads, just separate coroutines running around, and our system was fine, right? These were stateful, and again, we couldn't wait for C++ to come along and give us the ones they're giving us now. All right, so here I am, and I'm writing my application. So I'm going to have my service, and I'm going to say, look, I have this thing called service A, and it's going to have a request and a response A. So easy, just use type alias, right? In my main, I'm going to create one of these services. I do it in my main because, like I say, I have to be very careful with lifetimes because I'm using coroutines. So if I create it in the main, spin up my coroutines, spin them down, main exits, I'm sure that this thing doesn't go away. Next thing, I need to do error handling. So this is the way it was decided to do it here. I'm not a huge fan of this, but I can certainly live with it unless it's a problem. And the idea here is we'll just drop the response into this function. It'll check all kinds of fields inside of it. And if there's something amiss, it'll just throw an exception. And it'll propagate back up to where the handling of the responses are, and it'll just send out this was an error to the user. So it works. Yeah, let's not talk more about exceptions, just upset me. All right, so let's get to action X handler. So we have a bunch of different actions coming in. Actions to create all kinds of different trades, actions to do modifications, actions to do splits, tons and tons of these actions. So I write a handler for each one of these, and I put a service A reference in it, right? Because my service A won't hold state. And I'm going to have an execute, so I'm called with this action X, but there's action Y and action, tons of them. And the way I'm going to do this, I'm going to say, look, I need a request, because that's what's going out to this service. And I'm going to have a lot of code and a lot of logic, and what it's going to do is pack that request up. And once that request is properly formed, I'm going to say, listen, send it out to the service. That's going to give me back a future. And then I'm going to say, look, resolve that future into its actual value. So if there's something there, it will get it. If there's an exception, it'll throw, and that'll just go right up to where my catch is handling this. All right, but I will get the result. And then I just say, listen, check response for, remember this thing here is that response carrier. It has that unique pointer inside of it. I'll just dereference it. Boom. It'll go into the check response. And I can make bunches and bunches of these handlers. So any questions right now? Yes? Good question, right? So the question is, look, I did a send, got a future back, and I immediately called get. Well, isn't that just the equivalent of a blocking call? Think of this thing as inside a coroutine. It's just blocking a coroutine, and there's 50,000 requests in flight, right? Coming as everyone comes in, get your coroutine, off you go, right? So yes, and there are a lot of places in the system where it fans out, right? So it really does become parallel. But yeah, that's I've got asked that before, so that's a good question. All right. Any other questions? All right, so testing. All right, testing is something, I don't know, I'm very high on, right? Both unit and system testing. So I do a mock. All I'm going to do is I'm going to inherit from the base, which is that service A. All right, this is one of the idioms we use. We just inherit from the base. And then I'm going to have a send function that has the same signature as what we have on the regular base function. And then I'm just going to say, I'll use, it's a mock const method, takes one argument. It's going to be called onSend. That's what and it's going to take const request reference and return a future carrier pointer. The reason we're doing that is just I got to waltz around the fact that these things don't have copy constructors, and this is just easy in the test environment. Right? I can take a few liberties. But this is essentially my mock service. I will be able to drop this in to any handler in the test. All right? But there is a little wrinkle. If I drop that in to a service A reference and just call send, what's going to happen? It's just going to call the base function send, right? So everybody sort of take a deep breath. I'm going to make it virtual, right? So that I have runtime dispatch. Now, people go, oh my God, you're using virtual, you're going into a virtual table. It's the worst thing I've ever seen. If I need to make that statically polymorphism, I can do it. There's plenty of tricks for it, right? I can do it, but I'm not going to do it now when it's not a problem. Question? All right, someone said, I've already got a future, I don't care about virtual. Even before that, I didn't care about virtual, right? And the reason I didn't care is if someone came to me with numbers and said, look what this is doing to our system, I'd say, okay, I will get rid of the virtual. But until then, I'm going to do it the easy way and the way people can look and easily reason about. All right? Okay, so let's keep moving on. So testing. Here is my ActionX handler that I'm going to be dropping this mock service into. So all I'm going to do is make a fixture. I'm going to say, look, I got a mock service template on service A, right? So I'm going to do the base class. And then I'm going to initiate my X handler with the service A. And then I just put an execute in there to keep some of the code bloat out of the test, right? So you can call the handler.execute. And let's just get a little aside here. And what I'm doing, if I had a simple function like, I don't know, double something, whatever goes in, whatever goes out, that's all that's going on. But in this type of function here, where I call the execute, an action is going in, a future is coming out, and there's a request that's hidden from me. Right? And that request is really where the money's going to be made. I've got to make sure that request is correct. And I don't want to do it by checking in production, right, and having the clients tell me if it's good or not. Right? So I need to be able to reach in and get at that request. So how I'm going to do that in the testing is I'm going to say, look, I have my test fixture. I'm going to have a request, a local request. I'm going to build myself an action. In this case, I'm going to build one that's going to fail. All right, I got to build myself a response so I can satisfy the mock return, but it's uninteresting. And then we have the expect call that says, listen, I'm going to call on send on service A with a parameter, and I want to save the argument that it's called with to my local request. So inside those handler, all that logic for creating the request is going to happen. When it calls my send here in my test, I'm going to capture it in that request REQ. So I can examine that request. Right. Now here when I throw, because it's going to do the check response in there and throw because it's a bad response I get back, I'm going to make sure it properly throws an error. All right? That's the unhappy path, the one I don't want to be traveling too often. And then I have the happy path. Same thing before. I'm going to create a new action that has valid stuff in it. I'm going to have my response come back. And then in the same expect call, nothing different. I'm going to say, this time I'm not expecting it to throw. And now I'm going to take the request that I've captured what went on inside of my execute function. I'm going to say, listen, is the quantity 2? Is the broker ABC? And then here's something else you find in testing. So I don't know if you call it white box testing. They had a way to reach in to the state machine and persistence and find out that it actually went correctly, sort of like by putting your hand behind the curtain. And you can do that here as well. All right, I want to check that inside my caches and inside my state machine, everything looks good. All right. Any questions? So that's just basic unit testing, right? Which is not enough. You also need system testing, but I don't cover that here. So we put this into production, and we actually did put this into production. This is not, like I say, me just saying it goes into production. We put it into production, and time goes by. And as time is going by, more and more clients have been pulled over to this new system because it's replacing an old system. We get extra benefits here, which much more faster, much better throughput. The legacy system is having problems. That's why we're replacing it. And because more and more customers have been dragged over, it becomes more and more important this thing does not fall over, does not go down, and certainly that I don't take it down. Right? So. But, as normally happens, enough time goes by, change is in the air, right? And change is something that makes your system break. So what are we going to do? Well, a directive came down from, I'll call it on high, from management that said, listen, we need to change how things are going on, right? And even though this is a brand new system, brand new meaning it's 5 years old, by the way, right? That's what the brand new still means. Service A is to be replaced by service B. Because it's more direct, better throughput, better latency, less points of failure, this thing is just going to give you a big lift in what's going on. All right? However, the new service B, although it's an established service, it's never connected to us, so it had to do some build out on its side. Right? So somewhat experimental. So, it's not like I have much guarantees here. So if I go back to the slice of the system we were looking at earlier, right, this is what we had. What we're looking to do is put this thing in service B and just get rid of service A. This is how we want to end up. All right, once we do this, all those goodies running much better, clap on the back, good reviews at the end of the year, all of that kind of thing. So Here I am, what do? Well, I think it's pretty straightforward. All I'll do is I'll make a check response for response B, which after all is completely different. So there's a whole bunch of other checks, but I'll still throw an exception if something goes wrong. And then all I'll do is just say, look, all the service A stuff, just change it to service B. I'll show you that again. Just all the service A's just become service B. That's all. All right? And then at that stage, I can get rid of the check response for service A. Done. I've absorbed an enormous amount of change with relatively little effort. All right? Anyone see this as any problems, problematic? You can see anything that might go wrong here with this approach? It is. It's a very big step.
Is it common that you need both system A and system B at the same time?
Not the way I'm doing it here. So the thing is, I just got asked, the audience, isn't this a big step? And someone else said, yeah, wouldn't you want to have both systems around? You're right. This approach is very risky. And certainly in the environments I work in, which are not fault tolerant. I mean, if you have a system where it's in development, or it's something where you can take 2 or 3 shots to get it right and no one really cares, yeah, do it this way. This is fine. Roll back, roll forward, do the dozy-do. I can't roll back and roll forward. If I roll the software back, I'm rolling back 10 other changes that may be business critical at the time. All right? So this approach is risky, and even if the service B that you are connecting to is long established and proven, what I do know is your interactions between it and service B are not proven. How do I know that? Because we haven't done it yet. All right? And that is risk, and that's an intolerable level of risk for me. So straight swap is out. I don't have these options, right? What we really want to do, as someone else said out there in the audience, is that, look, we want to say for some period of time, I'm going to have service B running with service A. In the very beginning, nothing goes through service B, right? So I roll out the code and make sure I don't mess things up with nothing going through it. And then over time, I route more and more and more stuff through service B until there's nothing left going through service A. Probably nothing left going through service A for a period of time. And when that's done, I can safely get rid of it. All right? And no one has to know about service A anymore. That last piece where I got rid of it is something we do very poorly at. And when I say we, I mean all of us here, right? Not just like me and someone behind me. All right, the decommissioning. I see so much software where, oh yeah, this is hanging around. Does anyone use it? I don't know. No one decommissioned it afterwards, right? Because the decommissioning can be just as tricky or even worse as putting it in if you don't keep an idea of the whole life cycle of what you're doing. So let's go back and say, well, let's try a new way of doing it where I need the 2 of these around. So remember, on the left-hand side is everything that is one single file. On the right-hand side, I'm going to have many, many files. So all I'm going to do is duplicate everything on the left. So I'm going to make a service B, a new using, a new declaration, so I have an instance of it in main and a check response. And on the other side, where I'm going to have many, many handlers, I'm going to say, listen, put a service B in there, because sometimes I'm going to use it. And, I'm going to have a route function. And a route function, it's not very interesting. All it does, it goes into request and says, is the destination on my list? Yes, put it through service B. No, put it through service A. So it's not a runtime overhead. It's runtime, but it's not an overhead. And it has nothing really exciting about it. I wrote it in, 20 minutes, right? So here now, I say, look, some is going through service A, some through service B. How does everybody like this style of change? Yeah, you just have to nod your head. It's like an auction block. All right, I got lots of people shaking their head. Right, I got a couple of problems here. But the problems are only problems if I actually want to decommission this. Right? If I'm just like, I want to get this thing in and then I can go off and it's someone else's problem, maybe I don't care. But think of it this way, what do I have to do when I decommission this? I got to remove the service B. I got to go in and remove all the branching that's in here. Right? And if I have branches like this in hundreds of files, Now, one thing, how long do you think this is going to take me to get this phased approach happening? A month, 2 months? So I did this code change, I think about 1.5 years. And there's a guy in the audience here, one of my old workmates, who works on that project still. Have you got rid of that change yet? Close, right? By close, he means no, right? There is one user of this that is very complicated, and they've decided to do it the correct way, which I didn't think they were going to do, but it's got now an external dependency. So we're 1.5 years in. If I have 100 files, and I'm 1.5 years in, you can guarantee that someone's going to make changes in one side of this branch and not in the other. They're going to do stuff that's, you'll come along and say, let me just get rid of one of these branches. Oh, wow, there's extra stuff in here. Do I have to copy this over? Did someone think about the second branch? It becomes a nightmare. It becomes even more risky to decom. So for me, brute force is out as well, right? It's just as bad. It's probably worse because it's insidious. So let's start doing a bit of software engineering instead, right? Instead of just saying, let's get the change in. So what I like to do is write requirements, because if I don't write requirements, I tend to end up in very strange places and not realize I've gotten there. So my requirements are I'm going to localize meaningful changes. And what I mean by that is anything that's handling the routing, anything that's handling the different requests is all in one spot. So you can't mess with different versions of it. All right? I'm going to keep the global usage of this the same. That means that all my handlers are going to look in this conceptually like it's the same thing. We're not going to bring in branching and different ways of calling the code. We're going to satisfy the contract we currently have with all our global users, in this case our handlers, right? And that means we're going to minimize throwaway work, right? And the final decommissioning is going to be simple. Because I've thought of the final decommissioning, I'm going to, I believe, put myself on a better path. Now, I want to say watch out for unit testing, because I did all this on the actual code, and I thought, wow, I'm at the end, right? I'm close to the end of this. It's a matter of getting this thing deployed. And the unit testing, I was like, oh my God, there's so much unit testing code. It's actually the executable for the unit test is bigger than the server. There's thousands and that. There's 4,700 tests or so there when I was there. I don't know what there is now. It's probably doubled. And although in production code, you generally don't do funny business, you're not supposed to, or someone's supposed to catch in the code review. In testing, all kinds of funny business is fine. You can get away with anything as long as you're able to give a half-rational explanation. I know that looks bad, but look what I'm able to get my hands on to test. Okay, we'll turn a blind eye. Well, it's not going to production, right? And your mocks may have additional semantics. So doing that now, I want to keep everything with the same kind of viewpoint. So before I had a service A in main, all I want to do now is say, look, I have a service proxy in main. That works very much the same as the service did before. And my check response is going to take whatever that response from a proxy is going to be different, that I do know. Okay, and that's going to happen in 2 files, right? So that's on one side. Now remember, we'll get to it later. And on the other side where we have all these handlers, I'm going to say, look, I had a service A in there. All I'm going to do is change it to this proxy. And then down where I do the service.send, it's going to be proxy.send. So it's going to be exactly the same. I've changed the type and the name in the ActionX handler because I want people to know that it's not just a service A. All right, now, any good IDE will handle this. I mean, I didn't have to really sweat this. I put it into Eclipse. I don't know if we want to call that a good IDE, but when I did the refactor, it just changed all these for them. Boom. 300 files changed. Compilation will be good. All right? So what is this? I don't even know what this service proxy is right now. I got to go figure it out. So here's my service proxy. So what do I need inside of a service proxy? What? That's too vague. Someone said a service. What do you need in there? What am I going to send to? A and B. Right, so I need A and B in here because that's what I'm going to reach in for. What else am I going to need? Send function, right? We don't need routing. That's hidden away. So I have a send function. So it's going to look just like my service, right? It has a send function, takes a request, and returns this thing called a var rest future, and I've encapsulated all the routing inside of here. All right, now what is a var rest future, do you suppose? What comes back from a send of service A or B? One or the other, the future of whatever is in there, right? So this here, it's a variant of just whatever comes back. So I've just said, look, my service acts very much like my service proxy acts very much like my service did. And it's not like the send is doing, a receive or something crazy, right? The send is doing a send. Okay, now, I say, oh man, this was very easy. I'm glad I went this path. Put it in the compiler and let it rip. And I get, well, there's no number named get in a variant. And there isn't. I mean, there's a stud get that you can put in a variable, but that's a different show. All right, so where's my problem? Here, in my global use contract, I used to get back a future, and I would call the get on it, which would resolve the future into a value. All right, and I don't have this in a variant, so I'm going to have to do a small wrapper class, and I'm going to call this a result future. So there's my var rest future. There's my variant that came back from the send. It's going to just initialize that. And now what I'm going to say is, look, the get function in this thing here, if I do a get in the result future, it should do the same thing and just give me, the actual results. I shouldn't have the future about them anymore. Now I'm using something here, if you were at Timur's talk yesterday, right? It's a variadic. I'll show you in a second, but all I do is I say, look, construct yourself from these lambdas, and when I put it into the visitor pattern, it matches whatever's in the variant. All right, so I'll either hit the service A carrier or service B carrier. Didn't want to give you that right now. What is a var resp, right? If a var resp future is a variant of futures, what's a var resp, right? I just dropped the future. In other words, right, I'm going to block if there's nothing there. I'm going to take something out. So again, this here works just like a future, except there's a variant in it. But semantically speaking, it's doing the same thing. All right? Now, if anyone's interested, so here now when I do send request and do a dot get, my result is now the actual results. It's a variant, it's one of the other, but it's the same kind of meaning. Now here is this overloaded class that we use. So all it is a variadic. We just inherit from a bunch of lambdas. And I have a deduction rule that's a little different from what I think Timur was doing, in that I want move only semantics, right? So this just says move everything. Don't copy it. But it's not that interesting unless you like lambdas. All right. So when I gave this talk at CPP Now, some bright spark in the audience said, hey, what are you doing? That's overly complicated. Why not use a generic lambda? I was like, a generic lambda? Man, that looks really so much better. However, I can't just say in my talk we used the generic lambda because we didn't, right? So I have been tempted to put a PR in to change this, even though I'm not in that project anymore. Just slide that one in so my talk can drop a slide or two and make us look much more intelligent than we were. But anyway, now when I go here, right? My service proxy said, look, I got to send. We're going to just do the routing and return a result future. Easy peasy. All I'm going to do is let this thing rip in the compiler again. No member name res pointer invariant. That is true. All right. So what is the problem here? It's down here. Right? And there was an important lesson to be learned from here. Here, if you remember, I'm going to look for this res pointer as a unique pointer in my carrier, dereference it, right? So, hit the wrong one. And I'm like, okay, so here's this is the response carrier we had, right? And this is why we're reaching into the res pointer, dereferencing it. So my result now has to have this variant inside of it. And how am I going to say, well, I need a res pointer member in here? Okay, I'll do this. Give me a res pointer. Doesn't look very attractive to me, but that's how it goes. And then I got to dereference that and get back the actual results, so I'll put this in. Anyone think, look, I've solved the problem. This will now adhere to the global calling contract, but anyone like this? Anyone not like this? This is horrible. Right? I don't have any justification for someone's going to come along in 6 months after I left the project, probably my friend down there, and go, Pete was absolutely drinking or out of his mind. Look at this. What possible? Why is he taking at this point? And this goes back to a problem we had. The root of this is in the response carrier where we said access the member directly, which has a, sort of abbreviated name. We didn't want to say response point. There was too many alphanumerics, right? So what we should have done is said, look, if you want the response out of this, call get response and get it back. And stop reaching into pointers and manipulating them directly and stuff like this. And this abstraction would also help if somehow I get rid of unique pointer and put something else in. And this is one thing you should learn about abstractions, right? It's not just to build stuff up. It's also you can absorb change in an abstraction. And that's an important point. So here's this mess I had before. And if I change it now, here's how it reads, right? So my result looks sane again. People are going to say, Pete still has it, right? And check response looks better than dereferencing and reaching members and so just get response. Okay. So the problem here is I have made a semantic change to what's going on. I haven't just changed the type. I've made an actual change in how the code is called, right? But it's not a throwaway change. And I opened the change request for, 300 files, and that was the only change I made, right? I put an extra get response in, and I had all the result. I just did I think it was a text replace of all this stuff, the dereferencing stuff with this, sent it in and said, hey, take a look at my PR. It's hundreds and hundreds of files. I said, yeah, it's all just the same dumb stuff in it, right? So they passed it, it went in. That's another way of getting big changes in. You make it small and comprehensible. People are like, they feel safe. It's a safe change. So although I made a change here, it was a change for the better, and it's not one I'm going to undo because we made a mistake in the beginning. All right, so here's the handler now. And this will actually compile. What about result analysis? So if you remember, I had check response, that response A. I wrote my new check response for response B. How am I going to handle the proxy response? Which is a variant of either of these two. Right. Just like this is how we did it. Right. Again, the overload with the variadic thing. I really wish we could have just done this. Right? It makes us look so much better, but this is the way it would be done now. And in fairness, I think this was a 17 thing, and we had only moved to 17 at the time. But anyhow, I think this looks better. But again, all we do is we more or less dispatch it with the visitor pattern. Right? Whoever wants it gets it. Any questions, by the way? I'm going to move on to the testing piece. Yes?
I have a question. If we want to add more and more services, suppose if some product manager wants to do A/B testing with many services, for example, how is this better than using virtual functions? Because my understanding is stud variant also uses some kind of a jump table internally in order to switch between the service A and service B here. So in terms
I believe that jump table will be a lot faster than the virtual. But we did it that way just because it was the simple way to do it.
Okay.
All right? And I don't think we were too hot on inheritance and the virtual function in particular, right? I got away with it here, but mostly it was seen as we wanted to be performant. But this is just the way we did it. You could possibly do it that way, but I think it would probably look gnarlier, right?
Okay, thanks.
All right. Any other questions? Okay, so let's go to testing. This is our original mock service. Now, I can't get rid of this because there's service C, D, E, F, G being used by all of the parts of the system, right? So I can't just get rid of this, but I can just say, look, my mock service proxy is simpler, right, than the old mock service. All I'm going to say is inherit off proxy and do the send, right? Now, the send function on the proxy is virtual as well, right, because we're inheriting from it, so the inherit goes down. So, as testing goes, here we are. This is testing just the mock service itself, which I find incredibly uninteresting because it's like something I built. Does it work? Yes. That's just me playing around by giving. But anyway, we do an expect call saying, hey, call it, see whatever comes back, and check that we get the response. We're not actually inside a handler, so I won't even spend too much time to that. All as you can see is that when I change this thing here from a mock service to a mock service proxy, everything in red is that changed. And the only thing that changed is the name and the types. None of the actual calls changed. All right, so again, I can run that through an IDE. Hey, change this thing. Testing, the more interesting test, right, is inside my handler. So here's where I had before. I have a service A inside my X handler. I'll just change that to a proxy, and where I had a service.send, proxy.send. Right, we already covered that. That goes on. But in my text fixture, it just went from a mock service to a mock service proxy. And that was it. Right, that's the only thing. And my handler gets initialized by the variable. But again, there's no change to the calling code, just a change to the type and the name of the type. No. No. I'll explain that in a little bit. So, when I go now to do my test fixture, here's where I had before. I had to build an action X, and then I had to build a particular response for service A. So, what's my change here? All I do is I change the type of response, because I'm getting a different response. So my mock call says, give me something different. And then all I do is say it's a proxy instead of the service. Again, very simple changes. Easily absorbed, and when your compatriots see this, they don't go, oh my God, what's happening here? It's doing the exact same thing that used to happen before. And this is the unhappy path, so when I say expect this thing to throw. If I look at the happy path, again, what am I going to do? All I'm going to do is say what the response type that comes back is different, and I'm just going to have, instead of a service, I'm just going to have the proxy. So all very simple changes, but I've kept the meaning of what was done. I think the way it was done originally was good. It wasn't like, I said, this was really bad, but this was a good design. It's just we had a big change, and we wanted to keep that change in the same, I'll call it the same semantic universe as what was there before. And again, in this thing, if you actually see here, nothing goes on in the actual piece that's interesting, which is where I execute the function, nothing changes. It's just the setup of what's called. That's the difference. Okay, so now what it has is I have put in a system in production where I have this route. All right. And by the way, you are able to play with the mock the route behind the scenes. Right, to say, look, I want to flip it one way, I want to flip the other way inside your testing. Right, but I'm not covering that in the slides. But what I have now is a system and test that's able to go from A to B gradually. And over time, everything will be in service B. When I say over time, I mean over a gulf of time. Right? I'm looking at you, Jaden. Right? We have just one guy left. Right? Almost there. So what about when it comes to the decommission of this thing? How am I going to decommission this? Because, at least in my experience, the decommissioning is equally as risky. You almost have to put a bigger task force together, right? To decommission something, you're like, it's a legacy system, it's a new system, it's super critical. Oh man, what happens if we take this out? It's been in there 2 years, no one's quite sure. The old guy that did it has left, he's retired, right? No one knows how he thought. So what are we going to do? Well, let's look at decommissioning. So here is what we have. So over time, this routing has routed everything to service B, and it's been, I don't know, let's say 2 months. And I say, look, I'm quite happy to rip this out now. All I'm going to do is say, look, I don't need anything with service A in it in here now. And that just means that the variant only has service B in it. I don't need any routing anymore because I'm only returning a result future right from service B, so I'm only sending through it. And I get rid of the member. In one file, right? That's the key place. In one file. And if someone's done any funny business, it's only in this file I'll have to check for it. I won't have to go through 100 files and do it. So this is a stage one. I'll call it decommission. So who here would say, let's keep that kind of abstraction around in case a service C comes up? Or do you want to rip it all out and just go back to the vanilla service B like you had in the future? All right, you can't see, but a bunch of hands went up with the let's keep an abstraction around. But even if we have the abstraction around, we don't need to, oh, why would I do the variant with a single type in it? It's like, I'll have to explain to any new guy, that I'm not, a really bad programmer, right? It's just historic. I was coerced into doing this, right? So I can do a stage 2 decommission and just say, look, the result future is actually just the future now. All right? Throw out the result future. The send is just a send. Service B is just there. I'll have very little overhead. And this will be safe. Now, I've talked to the guy who's running this whole thing. I actually talked to him first. I didn't know I would have one of my old work colleagues here about how the decommission was going. He said, I'm on one guy, just like was said here. I said, have you any worries about decommissioning this? He said, no. I said, the decommission of this is going to be very safe. Right. Now, let's go for a reality check. I'm down into the last 10 minutes. So I'm showing you what I'll call a simplified version of the world I work in, right? In reality, what was going on here is request A was a vector of roughly request B, right? And when we sent that through service A, we got a response back which had a future of all these responses in it. Now, that service A wasn't particularly concurrent. It was more or less, I think, sending it out, waiting, sending. It took a long while, could fail. It was an extra dependency we didn't really want. But that's what was going on. So what we were actually doing was skipping over it. Right, so what we now have is request B, but we'll have lots of these request Bs. And we have batching operations where we'll take a big group of these and try to send them out. But now, I'll show you it visually. When request A comes in, if it goes out the request A path, or a single request is sent to service A, that gets done, and then we get the future back. But when we send out request Bs, we just send them all out in a bunch of coroutines, right? They go to a bunch of service Bs, and we get back to futures in whatever order they come back in, right? And if we have a whole group of these futures, we're able to say, look, if one of these throws an exception, then don't wait for the rest of them, right? So you can do these little optimizations, but again, it's not very germane to what we're doing here. So how did we get here? Well, the first thing we did remember was we had this really wide API. So now I have a system that I know is only using async. It's using standard future promise semantics, and no one's doing copying without a good reason, right? Because it's easy to spot. So that's what we did with the API use, and this is something I don't think we cover very, very much. And we talk about, again, all the producing of it. We're going to use an API, how do we properly constrain it? And we did it where we said we will make that choice that we're going to channel good practices via a wrapper with constraints, and we got move only data, future promise, layer of abstraction. Now, when I gave this talk in a dry run, when the guy said, what, are you afraid of people using C++? You don't think we're all very bright and stuff? It's like, I'm only going on the historical data, right? I'm not pointing a finger at any particular guy. I'm just looking at the history of what I've seen in 30 years in the industry, all right? So that was the first thing we did. That was laying the table. But then remember, we had this big change come in, and this was a punishing change that could have really caused a lot of problems. But we got some requirements together. We said, look, let's keep all the stuff to do with doing things different in one spot, and actually in one file, one or two files, right? And then if we keep our calling contracts the same, because I thought they were good, mostly, right? Remember I changed the one that I didn't like, right? And because of that, there's really no throwaway work. The final decommissioning is simple, and it's only mattering it into my hour file and throwing out the check response A, right? And I can even throw out the proxy version of it. Okay, but I kept the final decommissioning simple. So the end game of all this, right? Why don't I just say, let's just brute it in, and instead of real men, just put it in straightforward and see how it goes, right? I can take it, right? Is that a large-scale change in requirements does not necessarily mean a large-scale change through your code base. And that's the thing that's very risky, okay? So the whole idea here of this talk is how do we give a better delivery of change in fault-intolerant systems? How can we deliver something that has got low risk attached to it and taking the whole lifetime of it, not how do I get it in? How do I get it in and the other thing out? Right? And because of taking that viewpoint, I actually think I made my life simpler because I took a bigger slice of the viewpoint. Right? So how do we do a better delivery of change? We mitigate production risk. And we do that by sound engineering principles. Right? Not changing huge amounts of our code unless you think it's really warranted. All right, that's it. Thank you. Now, I have a list of Godbolt listings. I obviously can't give you the Bloomberg code, but I did mock everything up in Godbolt, so you can take a look at this. If anyone has an interesting way of doing it different, like the inheritance or anything, do it on Godbolt and call me over, right? Or send me a link, because that's how I got the generic Lambda. All right. Other engineering talks I've given, like I say, I try to concentrate on the real world. This is where I live. Is retiring the singleton pattern and redesigning legacy systems. Right. Now, one thing I will say here is in the review of this talk for CppCon, I got one bad review. Right. And the review said, this does not talk about what pattern. Is it producer, decorator? What type of pattern is this? I can't tell what's going on, like terrible talk, right? So what pattern did I use there? Anyone? No, it's the reality pattern, right? Or I heard it called the Muldoon reality pattern, right? In other words, I live in the real world, and I cannot take one thing, if I have anything other than a simple academic problem, which I think is probably where this guy does his stuff, right? Is that in the real world, I got to bring many different things together, and that's where engineering comes in. All right, and before we get to questions, Bloomberg is hiring, and we have a booth out there if you want to talk to us. Questions? Yes?
I have a question. I'm a newcomer to C++, but I've seen some of the talks on type erasure, which try to do what we did with converting from service A to service proxy or service B to service proxy. And my understanding is there is a bit of overlap between how we use stud any and stud variant in this example and things like that. Am I correct, or do you have any thoughts on the performance penalties?
Well, the thing about type erasure is you can put anything in there, right? And a variant, you're keeping it in the closed system. What you're saying, I'm just telling you what it can be. I see using the more constrained way of doing things better, right? Same way I could have said, look, my proxy, let me template it on a variadic number of services, which would be something that I would do. Maybe I'd probably have fun doing it, right? But it's not necessary, right? It's making things more complicated, harder to understand. People come in after me and they don't have a way of figuring out, what is he doing here, right? Or we change how we use variadics 5 years down the line and no one can understand what I was doing today in it. Okay, so there's 100 different ways of skinning the cat. I just think this was a particularly good way of doing it.
Okay, thank you. There are 2 questions from the online audience. This is with reference to slide 48.
48, okay. Is this it?
Yeah.
Okay.
The question is, won't a reference member in the struct, in the result struct, be problematic with reference to copy and move semantics?
Possibly, but remember, we're using this in a local context, right? This is not traveling anywhere. We're checking that result, right? So we get that result back. We're dropping the reference in at the check, right? And then we're moving on. So it's used in a local context. The reference won't matter.
Okay. One more question.
By the way, this is the way I didn't want to do it, right? So I hate defending this particular slide, but okay. Is that it?
There is one more question.
Well, hold on. Let me get one of the live guys here.
Yeah, thanks. You mentioned that when you were decommissioning service A, finally, from the proxy, that you removed the variant. because you thought someone might come along and like be confused as to why there's a variant with only one option in it, right?
Right.
So you just made it a direct value. I feel like there's still the potential for confusion as to why the service proxy layer even existed at that point, because at that point, maybe its only job is just to, it seems like it's just a pass.
No, it is just a pass-through, right?
Yeah.
The very last slide I showed there is a pass-through.
Yeah.
And that's easy to reason about what it's doing. You may say, well, why, right? Why is it doing there, right? And it's
Well,
there as an abstraction layer.
Yeah, I think it's more of a meta question to that, which is like, is there anything else you can do to like mitigate a new developer coming across that and asking that question, you know, and then maybe opening a PR to remove it?
I don't know, better comments and documentation,
Comments,
maybe. I mean, you know, you raise a point, but to me, you know, we've traveled the journey and we've come back to where we have something very straightforward, easy to reason about.
Yeah.
And that really is the core of this thing. You know, is it easy to reason about the old system? Well, if it was, reasoning about this change is relatively the same, right? Certainly in the use of it. It's like, I don't have to think about it. I do the exact same thing I used to do before. If you want to get in, if you're in, you know, in part of the, you know, the proxy design, or you say, like, the proxy has to do some other kind of thing, then you have to know it a bit deeper. But I still think it's locally reasonable, and you can, you know, you can make judgments on it straightforward.
Cool, thanks.
And it was a question, I don't know, have I time still?
Yeah, one last question.
Okay, this is the last one.
Did you send mock transactions through B before real transactions? That's the question.
Did I send mock transactions where?
Did you send mock transactions through B before real transactions? I think he's referring to the
No,
service.
so I think what's been said is, what did I have, the very first time service B was in production, the only thing that would route through it is what we have test clients and test brokers, and they're not real. And you know, their state doesn't really matter, only as far as checking. It's not like it's going to go anywhere. So we use just essentially test references as our data in the beginning.
Okay, thank you.
All right. Okay, well, I think we're done. Thank you.